Welcome to Quest Studio Physics students. Students, in this class we are going to learn about the expansion of the material students. Actually, it is the thermal expansion of the materials. All the metals expands on heat. The expansion take place along the length, along the area. This area is said as the superficial, and third one is the cubical expansion, and we call it as the volumic expansion of the students. Okay, students. First, we have to learn about what is the linear expansion is. Linear expansion is nothing but the expansion along the length of a solid, students. If you compare all the expansions, linear expansion is more when compared to the aerial and as well as the cubical expansion, students. To understand this, just take a metal rod. Okay, we are taking a metal rod. Okay, students. It is a metal rod we took. Yes, students. And this metal rod is fixed at a rigid support, students. The metal rod, which is fixed from a rigid support, students. Initially, say the length of the metal rod is equal to L1 at a temperature of T1 degree centigrade, students. We raise the temperature here from T1 to T2 degree centigrade. The elongation is higher along the length. That's why it gets elongated in this way. Okay, and finally it has a length of L2. Okay, students. And the elongation, this is the elongation. We call it as the delta L. L is the difference between the two. Okay, students, here we have to find out what is the quotient of linear expansion is. If you ask this, you will understand the elongation in the length depends upon the two factors. One is the length of the rod and second is the change in temperature. That can be written as like this, students. The change in length. Okay, L2 minus L1 is directly proportional to initial length of the rod multiplied with change in temperature. Or it can be written as L2 minus L1 is equal to, we are taking the proportionate constant as alpha, L1 into T2 minus T1. Or we can write it as L2 is equal to L1 of 1 plus alpha into T2 minus T1. Is a formula which is used to find out the final length. In the same way, it can also be written as alpha is equal to L2 minus L1 by L1 into T2 minus T1. Then what is alpha? Alpha is the quotient of linear expansion, students. What is the definition of the alpha? Simply it is the ratio of the change in length to the initial length by raising the temperature to 1 degree centigrade. Okay, students. Alpha, quotient of linear expansion. Alpha can be defined as change in length to original length by raising the temperature to 1 degree centigrade. Say this, for example, okay, change in length is delta L and initial length is L and change in temperature is delta T. Okay, it is the formula to get the linear expansion. Alpha is equal to delta L by L into delta T. Then we can write the units of this. Okay, students, alpha is equal to delta L by L into delta T. Delta L is change in length. Obviously, it is the length only. In MK system, it is meter by meter into degree centigrade. Meter get cancelled, and what we had, alpha has the units of degree centigrade inverse or Kelvin inverse, students. It has the units of degree centigrade inverse or Kelvin inverse. It's a quotient of linear expansion, students. Quotient of linear expansion is nothing but the ratio between the change in length to the initial length multiplied by temperature difference, students. Practically, this coefficient of expansion is very small, students. It is in the order of 10 to the power of minus 5. The coefficient of linear expansion is in the order of 10 to the power of minus 5, students. Students, already we derived an expression for quotient of linear expansion, students. That is, we had alpha is equal to L2 minus L1 by L1 into T2 minus T1. Now we are going to derive one more expression for the quotient of aerial or the superficial expansion, students. To understand that, we have to take a plate, say it is the square plate, which has an area of A1 at a temperature of T1 degree centigrade, students. This is the metal plate which has the area of A1, okay, at a temperature of T1 degree centigrade, students. We raise the temperature from T1 to T2 degree centigrade, students. Then area has been increased. The area is increased to A2, students. It is changed to A2. Okay, students. The area expansion depends upon the two factors, students. One is the initial area of the metal plate, and as well as the temperature difference. Then we can write it as A2 minus A1 is proportional to A1 into T2 minus T1, students. Or we can write it as A2 minus A1 is equal to beta into T2 minus T1, students. Okay, beta is quotient of aerial or superficial expansion, students. Beta can be had as A2 minus A1 upon A1 into T2 minus T1. We can define the beta as like this, students. It's the ratio of change in area to initial area by raising the temperature to 1 degree centigrade, students. Okay, our final area can be had as A2 is equal to A1 of 1 plus beta into T2 minus T1, students. Okay, it has the units of degree, centigrade, inverse, students, or Kelvin, inverse, students. It is the quotient of aerial or superficial expansion, students. Let's go with the third of this. The third expansion is quotient of cubical expansion. The third type of expansion is what? Quotient of cubical expansion, students. Okay, what is the quotient of cubical expansion? Okay, let's say a cube okay, students, it is the cube. Okay, students, it is the cube which has a volume of V1 at a temperature of T1 degree centigrade, students. We raise the temperature to T2 degree centigrade, the volume being changed to V2, students. Is the volume which is changes to V2. Okay, students. Here, change in volume is directly proportional to the initial value and as well as the temperature difference. Then we can write it as V2 minus V1 is proportional to V1 of T2 minus T1, students. Okay, students. Or it can be written as V2 minus V1 is equal to gamma. We are taking the proportionate constant as gamma V1 into T2 minus T1. Or it can be written as V2 is equal to V1 of 1 plus gamma into T2 minus T1. Okay, students. Or gamma is equal to V2 minus V1 by V1 into T2 minus T1. Or we can write it as delta V by V into delta T. Units as same as linear and as well as the areal expansions, degree centigrade inverse or Kelvin inverse. These are the quotient of linear expansion, areal expansion and cubical expansion, students. We are noting them as alpha is equal to V2 alpha is equal to L2 minus L1 by L1 of T2 minus T1, and beta is equal to A2 minus A1 by A1 of T2 minus T1, and gamma is equal to V2 minus V1 by V1 into T2 minus T1. These are the three different types of expansion, students, in case of solids. And alpha is L2 minus L1 by L1 into T2 minus T1. Beta is equal to A2 minus A1 by A1 into T2 minus T1. And also gamma is equal to V2 minus V1 by V1 into T2 minus T1. Students, now we are going to find the relation between these three quotient of expansion, students. Relation between the different types of, that means what? The three expansions. That is relation between alpha, beta and gamma, students. Let's say it is a cuboid whose length is equal to breadth and as well as the height, students. It's a cube. This, students. His length is L, breadth is B, and height is H. Let's take length is equal to breadth is equal to height, and we are taking it as L, students. Okay, students. That means its all dimensions are equal. Okay, we have to find out the relations. First, we will find the relation between alpha and beta. Then after alpha and gamma, students. Let's say initial length of the each side is L1. Okay, students. Initial length is L1. Okay, initial length I am writing. Initial length is equal to L1. Similarly, initial temperature, okay, is equal to T1 degree centigrade. Final length is L2, and final temperature is equal to T2 degree centigrade. Okay, let's say the initial length L1 is 1 unit. We're taking it as the 1 unit. And initial temperature is taken as 0 degree centigrade. Okay, final length is L2 only. And final temperature is 1 degree centigrade, students. We had an equation, students. L2 is equal to L1 of 1 plus alpha into delta T, students. To get the L2 value, I am using this equation. L1 is equal to 1 into 1 plus alpha into 1. What we had, it is 1 plus alpha. Final length is equal to 1 plus alpha, students. Okay, students. Now we are applying, we are first finding the relation between, what is the relation? The relation between alpha and beta, students. First we have to find out the relation between alpha and beta. We are writing the beta value, students, as you know that beta is equal to A2 minus A1 by A1 into T2 minus T1, students. Area is the square of the length, students. Here, L2. Area can be written as L2 square minus L1 square by L1 square into delta T. It is 1 degree centigrade, students. L2 square. We had the L2 as 1 plus alpha whole square minus L1 square. 1 unit I said. It is 1 square by 1 square into 1. What we get? 1 plus alpha whole square minus 1, students. It can also be written as, it is in the form of a plus b whole square. 1 plus alpha square plus 2 alpha minus 1 here, 1 get cancelled. And we had alpha square plus 2 alpha. Here beta can be written as 2 alpha, students. Here we are neglecting this term. I already told you the quotient of linear expansion is in the order of 10 to the power of minus 5 centimeter. Sorry, in the order of 10 to the power of minus 5 per degree centigrade. Here, think it is squared, then its value is very small. That's why we are neglecting the alpha square and we got beta is equal to 2 alpha. In the same way, if we go further, we are finding the relation. Now, relation between alpha and gamma. Okay, students. You know that gamma is equal to V2 minus V1 by V1 of T2 minus T1. Okay, volume is cube of the length. Then you can write it as V2 is equal to L2 cube minus L1 cube by L1 cube into 1 degree centigrade. L2 cube. L2 we have 1 plus alpha whole cube minus 1 cube by 1 cube into 1. It is in the form of a plus b whole cube. That is a squared 1 square plus b square plus 3 alpha into 1 into alpha plus 1 minus 1. Then it can be written as 1 plus alpha square plus 3 alpha square plus 3 alpha minus 1 here, 1 get cancelled, and we get 3 alpha plus alpha square plus okay, students. Here we are taking the volumic expansion, students. Here V2 minus V1 is V1 into T2 minus T1. Further it can be written as 1 plus alpha whole cube minus, okay students, 1 cube by 1 cube into 1, students. Then it is in the form of a plus b whole cube, and we can write a cube, 1 cube plus b cube plus 3 alpha into 1 into a plus b, 1 plus alpha minus 1, students. And it can be written as 1 plus alpha cube plus 3 alpha plus 3 alpha square minus 1. Here 1 get cancelled, and we get 3 alpha plus alpha cube plus 3 alpha square. Here what we did here, we neglected the higher power, students. Alpha cube and 3 alpha square being neglected, and we got gamma is equal to 3 alpha. Gamma is equal to 3 alpha. Then the relation could be written as alpha is beta is gamma is equal to 1 is 2 is 3, students. Okay, students. Alpha is beta is gamma is equal to 1 is 2 is to 3. It is a relation between alpha, beta, and gamma students. If you like this class, please subscribe my channel and forward to your friends.